Okay, so now we're going to do question number 3 of the packet, which says the diagram shows a point P, which is 12.3 meters from the base of a building of height h. The angle measured to the top of the building from point P is 63. So part A asks us to calculate the height h of the building. So, first of all, to do this, we have to consider which to use, whether the cosine, sine, or tangent. To help us, we can use the SOHCAHTOA. And since we're working with this angle, the longest side will be labeled as the hypotenuse, the side opposite to the angle is the opposite side, and the one on the bottom will be the adjacent. And since we know what the adjacent side is, and we're trying to find the opposite, those are the sides we're going to be working with. And so opposite and adjacent, meaning we're going to be using the tangent. So first, what you're going to do is write the tangent of 63, the angle, equals h over 12.3, because it's opposite over adjacent. Next, you're going to get rid of the 12.3 so that h is alone. So that would look like this. And then when you put that into the calculator, it will give you a really long number. 140. So, to make our lives easier, let's put that into 3 significant figures. It would be 24.1. So that is part A. Okay, so then part B states that consider the formula h equals 4.9 t squared, where h is the height of the building and t is the time in seconds to fall to the ground from the top of the building. Calculate how long it would take for a stone to fall from the top of the building to the ground. So, to do this, since we already know h, we can write the equation like this. And then we have to solve for t, which is the time to fall to the ground. So first of all, we're going to divide both sides by 4.9. Then that'll leave us with 24.1 over 4.9 equals t squared. Then to get t all by itself, we will do the square root of t squared and the square root of 24.1 over 4.9. And then if you put that into the calculator, it will again give you a really long number. And so we can put that into the 3 significant figures, which is 2.22. So this would be the time that it takes to fall to the ground.